What's up, everybody? Today I'm going to show you how to do a traffic light using the Altera DE1 educational board, FPGA. And before I start, I had done this program before using the Arduino and the PIX, but today I'm going to use the Altera, show you different ways, and I think it's pretty cool. Let's just make a folder real quick, name it light. Open the Quartus 2 software. I'm currently using 13.0 web edition. Go to open now. We're going to create a new project. Click next. Go to that folder that I just created in my desktop, which I called it light. And I'm going to grant it light. Click next. Next. I'm using the Cyclone 2. Let's look for the chip that I'm using. Click next. Next. So information, finish. Okay. And this is a quick way to do a simple traffic light. It's not the best in the world, but it works. Go ahead, click new. And we're going to do a black diagram. Open this up because we're going to use 2D flip-flops. So I'm going to double click. I'm going to put D. Altera, folders. If I click D, J, F, F, there it is, okay. D flip-flop. Click on that. Put one here. Double click. Put another one here. Notice that it's only showing my Q. It's not showing my Q knob, so I gotta add a knot. Go ahead and click that. Put that there. Double click. Put that there. So we're gonna have let's put a click. Just click on that when the icon comes up. And I hate when that does that. Go ahead, click there. And here we go. Okay, so we got our Q's and we got our Q knot ready to roll. We have that going. So we're gonna do we're gonna have three output, which is gonna be our red, yellow, and green. So I'm gonna go ahead, click type output. This output 1. Double click. Output 2. Double click. Output 3. Name this guy red. Name this guy yellow. And this guy green. Alright, so we got a 3 lights with 3 outputs. Let's wire our D flops. We're gonna have a clock as an input. Go ahead, click input. This guy is gonna be a clock. And I'm gonna name that clock. Clock is going to be an input. So if you look at the schematics to do, we're going to do this. Put an AND gate here. AND gate. Look for it. Put this AND gate here. Q. To this guy. This guy is going to go here. Okay. So it's going to come back to our D. Right there. Oh. There's a node, and this guy is going to act as also as a clock for my next D gate flip-flop. Once we have that, this guy we're going to have it going towards our red. And also this guy's gonna add that's our the input. Okay. And then this obviously is gonna be a green. So there's a algorithm for our traffic light. Just one traffic light. So once we got that, you could do your clock. It could be a switch, or you could use the push button. But we're gonna use the board's internal clock, which is the 50M. So I'm gonna head into right click there. More functions. How arithmetic to go to all the way down here to our counter. Go ahead, click that. This guy's gonna pop out. Yeah, VHDL. Click next. Since we're using the 50 meg, we know that it's 26 bits because we want to turn the 50 meg to 1 second to change the frequency to 1 hertz. Okay, next. Oop. Yeah, we're gonna play binary. You could change this to if you like, but just keep playing binary. Click next. Click next. Next. And we're finished. Okay. Blah blah. Okay. Yeah. Okay. I'm gonna click nope. I'll put this guy here. And once that guy is done, that's fine. Put a wire here. And you see, notice how it's really thick. The line is thick. It's because it has all these vectors. The 26 bits from 0 to 25. Just gonna rename this Q 25 dot 0 close square brackets. And the input for this guy is gonna be a clock. The built-in clock. And I'm gonna name this clock 1. This might seem a little tedious, but trust me, it's faster than the coding. Alright, so we got this is gonna be our the clock from the board. It's gonna go to this counter. It's gonna count up, and then we're gonna have to have an output here. We're gonna put an output here. This output is gonna be this guy right here, and we're only gonna take 1 bit out of there, which is gonna be the last bit, which is gonna be 25. Once the 25 bit reaches this guy, this is gonna be the output. So you don't need to connect this. This knows that it belongs to this guy. So what I'm gonna do is just put a wire. I'm gonna put a wire from this guy, and I'm gonna put a wire here. It's gonna be our signal. So I'm gonna put a signal from here to here. Okay. So once the 25th bit, 26 bit comes out, it's gonna trigger this clock. So it should be 1 second every time I hit it. So if you look at it, we're gonna use this. I'm gonna use as my LEDs. I'm gonna use the expansion header right here. I'm gonna use this guy right here, and then what you're gonna do is you just gotta open the pin assignment. And if you use the expansion header, you look at this guy. This is the guy I'm gonna be using. So what you can do is read the guides for the pin assignment. Alright, so let me compile this guy first. Save. Oh. Oh, right here, that's the error. Let's do that, just try that again. Okay, everything seems to be working. Compiling, no errors. And once again, this is not the best way to do a traffic light, but this is, you know, it does the job. Okay, so we got here, everything went well. Now let's start assigning in. For output, the red one, you're gonna go here, you're gonna go to pin assignment. No, pin planner. This guy's gonna come out. Hang on, let me close this. Let me close that. So what you're gonna do is for the red, for the green, the location, we go ahead, put this on the side, and let's look back to our PDF. And I'm gonna use for green, I'm gonna use this guy here. So it's gonna be B13, this guy. So I'm gonna go ahead location green. I'm just gonna type B13 and automatically assigns it, already knows. Then for my red, I'm just gonna keep them all together. So the next guy up, it will be this guy, B14. I'm gonna type B14. No, that will be for my yellow. My yellow will be B14. My red, it's gonna be B15. Okay, so we got our LEDs coming out of there. And yeah, you can just look at this and see where I'm going. I'm using this guy. Alright, so let's use the internal clock. Like I said over here, my clock 1, it's gonna be my internal clock. And I believe the clock, see right here, pin L1 is my 50 meg clock input. So I'm gonna be using this guy right here. So I'm gonna go to clock 1, and like it says over there, it's L1. So we have our clock going. And now, that's an output, okay? An output and inputs, you know, once it's an output, it can be an input. So I have that as an output. And then I'm gonna put a wire from that output, from the output of the Q25, this guy, I'm gonna put a wire to my other clock, the clock that's gonna run the flip-flops. So my Q25, I'm gonna put it right next to, really close to where I had the other guys. I'm gonna put it B17, the knife. So B17. Yeah. Yeah, B7. No. Yep, B17. And the wire that's gonna come back to that, it's gonna be my B16. They're right next to each other. I just put a wire. I put a jumper in there. B16. And that's the clock that's gonna be running my flip-flops, my 2 flip-flops. Let's go close that. Compile. Okay, everything went well. Look back at my scan. Let's see, everything is, I got everything. Yep. Okay. Alright, now let's go ahead and program it. Load it up. Output files. Light. Start it up. 100% successful. And once you get that, you should get it working. Now, like I said, this is not the best algorithm for the traffic light because it goes to yellow every time. But it's just a quick way to show you guys how to use the internal clock of the board and the LEDs. And like you said, see right here, okay, see my wires? This big guy right here is just my my ground. The black one right here, the long one, is the ground. I could have used the other one. I believe it has two grounds. Then I got my red, my yellow, my green, and here's the jumper that I use from the as an output as the internal clock to the input to the my D flip-flop clocks. And let me show you again. If you look at that right here, see how it has two grounds, has one ground here, has a ground here, and it has a VC5, 5 volts and 3.3 volts. So any of the other pins you could use them as IO input and outputs. So that's what I did. Alright guys, thank you.